Welcome to the continuation of nonmetals. So far, we have looked at air, we have also looked at hydrogen. In the previous video, we looked at oxygen. In this video, we're going to take a look at nitrogen and we'll end, of course, with pollution. So this one is going to be a bit lengthy in the sense that we're going to take a look at nitrogen and we'll spend most of the time studying ammonia, which is a compound that is made of nitrogen and hydrogen. So in studying or appreciating the importance of nitrogen, we look at ammonia, which is one of the applications or uses of nitrogen. So as usual, just like hydrogen, just like oxygen, nitrogen is a gas, also a diatomic gas, and here are some of its physical properties. It has no color, it has no taste, it has no color, it has no smell. That's what it means by odorless. It does not burn and does not support burning, except magnesium, which burns with it. So it does not do or participate in any kind of burning other than when there is magnesium. That's when it burns. Then there is one fact about nitrogen. It is chemically unreactive due to the strong bonds between the nitrogen atoms in the molecule. So the two nitrogen atoms, they have a strong bond in between them. So for them to separate and to participate in a reaction involves bonds being broken and new bonds being made. So for the two nitrogen atoms to separate, it's not possible. It requires a lot of energy, and therefore nitrogen is not that reactive. But it reacts with hydrogen gas to form ammonia in the presence of an ion catalyst. So the ion catalyst forces this reaction of nitrogen and hydrogen, as we are going to see later. So normally nitrogen is not reactive unless when it is forced. How is nitrogen manufactured? So even nitrogen, we use fractional distillation of liquid air, just like oxygen. So what are some of the uses of nitrogen? It is used in the manufacture of ammonia. It is used to provide an inert atmosphere during the arc welding of aircraft parts and in the electric bulb. So the word inert atmosphere is an atmosphere where some reactive metals such as tungsten do not react because there are no chemicals to react with. Since nitrogen is not reactive, therefore if it is surrounding such a metal, then that metal won't corrode or won't participate in any kind of reaction, and it will serve its intended purpose. Then there's also another importance of nitrogen, which is its importance in the manufacture of proteins. So in our bodies, in plants, nitrogen is used to make proteins. Now that's everything about nitrogen. So the first use of nitrogen was in the manufacture of ammonia. So we're going to spend the rest of our time studying ammonia. So there's a difference between ammonia and ammonium. Ammonia is a compound. Well, ammonium, it's a radical. If you go back to valences, we talked about ammonium. So the way ammonium is, it's a radical, meaning that it does not exist independently. You cannot find ammonium just on its own. No, ammonium is always combined with other substances, or I mean with other elements. So you cannot find it just alone, independently existing. Its existence is dependent on others. It is always combined with others. Ammonium is a radical, while ammonia is a compound. So the formula for ammonia is NH3, well, for ammonium is NH4. So you should know the difference. So under normal conditions, ammonia is a gas. So how is ammonia prepared? So in the lab, ammonia gas can be prepared by the action of heating an alkali with an ammonium compound. You get an alkali and an ammonium compound, you heat them, then ammonia is going to be formed. Here's an example. So remember, ammonium compound is a compound that has ammonium, but when this compound which has ammonium, not ammonia, when you react it with an alkali, then ammonia is going to be formed. So here's an example. We have a base here, or an alkali, calcium hydroxide, which reacts with ammonium chloride. Then when this reaction occurs, we have calcium chloride, a salt being produced, we have water being produced, and we have ammonia gas. So this is the setup of the apparatus. So calcium hydroxide and ammonium chloride, they are reacting here. So as they are reacting, of course, there will be water and ammonia being formed. Of course, maybe the salt, which is solid, is going to remain. So one precaution that you have to take when you set up this experiment, this test tube must be tilted at an angle like this, so that the water that is formed should go this side. Otherwise, when the water goes back, then we're going to have real issues. It's going to be explosive. So always tilt it, otherwise you won't attain the desired outcomes of this reaction. So once you tilt it, then the water and the gas are going to flow here. The water will be here, and of course we're going to have the ammonia gas here on top. So notice that there is calcium oxide and calcium oxide tower, which of course it acts as a drying agent to dry the ammonia gas. So the method of correction is downward displacement of air. The reason is simple. Just like hydrogen, it is less dense than air. The drying agent used is calcium oxide. So one thing to note is drying agents like calcium chloride and concentrated sulfuric acid should not be used in this reaction. So concentrated sulfuric acid is the drying agent we used in the reaction of oxygen, but in this reaction it's not advisable to use this. This is because they easily react with ammonia. So what are some physical properties of ammonia? So it is colorless, but it has this choking smell. So when in the presence of ammonia, you feel a smell which is like urine or rotten eggs. I think urine. Yeah. So it smells like urine, and that's one way you can actually tell that there is ammonia here. Unlike nitrogen, hydrogen, and oxygen, which don't have any smell, ammonia has a smell. And I think this fact was discussed when we were doing qualitative analysis or identification of gases. Again, it is less dense than air. It is very soluble in water. It is easily liquefied. So once you have the ammonia gas, you can easily turn it into a liquid. So the importance of this point is it makes it easy to transport in tanks and cylinders. So you have the gas, you can make it into a liquid. Once you liquefy it, then you can easily transport it as a liquid. So this part is interpretation. Okay. So chemical properties of ammonia. First, it turns damp red litmus paper blue, which implies that it is a base or an alkali. It burns in pure oxygen with a yellow-brown flame. It dissolves in water to form ammonium hydroxide. So this is the reaction where ammonia reacts with water or dissolves in water to form ammonium hydroxide. Then another important one is it is a reducing agent because it reduces oxides to metals low in the reactivity series of metals. So the oxides of metals that are low or that are less reactive, such as silver, gold, they are easily reduced by ammonia, meaning that the oxygen from them is taken away when they react with ammonia. How do we test for ammonium gas? So the base test for ammonium gas is it turns damp red litmus paper blue. because it is alkaline in nature, like I said. Now go to the final part, industrial preparation of ammonia. How do we prepare ammonia in the industry? So we use a process called the Haber process. So in this process, ammonia gas is produced when nitrogen and hydrogen are reacted. We get nitrogen and hydrogen and we react them. Remember, nitrogen is not reactive. So for this process to occur, there must be conditions that forces the reaction. So before we can take a look at the conditions, the importance of this so-called Haber process, the industrial preparation of ammonia, is that it produces ammonia on a large scale. As you are going to see, it is an intricate method which allows ammonia to be produced at a very large scale. So what are the raw materials? Like I've said already, it's nitrogen and hydrogen. Where do we get nitrogen? We have discussed how to get nitrogen and hydrogen. So the sources of these raw materials are nitrogen, liquefied air using fractional distillation. I mean liquid air using fractional distillation. That's how we produce nitrogen, like we discussed. What about hydrogen? Hydrogen, we discussed also that in the video for hydrogen, we discussed that we can get it by reacting methane and steam. So this is the reaction, nitrogen reacting with hydrogen forming ammonia. So now for this reaction to occur, like I said, since it is since nitrogen is not that reactive, so how do we force them to react? So these are the conditions that are necessary for the Haber process to be possible. The first is there's a need for a catalyst, the ion catalyst. The second is the temperature must be between 350 degrees Celsius to 450 degrees Celsius. And the last one is the pressure should be 350 atmospheres, a very high pressure. So atmospheres is another unit for pressure. We have units like pascals, but atmosphere is also a unit for pressure. So this is a simplistic diagram of the Haber process. So I'll explain all the parts and you're going to see it is easy to understand. You can even draw it on your own. So what we have pipes here where we insert or we pump in nitrogen and hydrogen. So nitrogen and hydrogen are pumped in. Then once nitrogen and hydrogen are pumped in, they go here where they are mixed. So this is the mixer which mixes the two. Once they are mixed, they are passed through a compressor. So the purpose of a compressor is to make sure that nitrogen and hydrogen have a higher pressure exerted on them. Remember, for this we need a high pressure. So we make sure that we exert that high pressure using the compressor. So we have attained one thing, we have added the needed pressure. We are remaining with temperature and a catalyst. So once that happens, we go to this part. So from here, the nitrogen and hydrogen are going to move through this pipe, then they'll come here. Okay, so once they are here, this is called a catalytic converter. This catalytic converter is made of beads of iron. So there are beads of iron, hot beads of iron here. So these beads of iron, they act as a catalyst. Remember, we need a catalyst. Okay, so the Haber process, when it comes to temperature, it is designed so that the temperature of 350 to 450 is provided. So with that being said, the catalytic converter, the ion catalyst, is going to produce nitrogen, hydrogen, and ammonia. So once we have nitrogen, hydrogen, and ammonia, then there'll be the three, nitrogen, hydrogen, and ammonia, are going to be taken to a cooler. So in the cooler, remember, ammonia is easily liquefied. So ammonia will turn into a liquid, while nitrogen and hydrogen will still remain as gases. And these two, nitrogen and hydrogen, by the way, the cooler is this part here. So maybe we label it cooler. So these two, nitrogen and hydrogen, they are going to go this side, then liquid ammonia will be pumped into this storage tank here. So here in the cooler, the liquid is going to come here where it's going to be stored. Well, the nitrogen and hydrogen are going to be pumped back to the system so that they react again, so that they produce some ammonia, which is going to be liquefied and collected to the storage tank. If there are some nitrogen and hydrogen remaining, again, they're going to be taken back, and again, they'll be pumped into the catalytic converter till all of them are used up. So this is actually what makes it more efficient, because if there's any remainder of the nitrogen and hydrogen, they are going to be forced to react till everything is used up. So this is the Haber process. So in summary, nitrogen is not reactive. That's the fact. To make it react with hydrogen, a process called Haber process is used. The two gases are mixed. That is nitrogen and hydrogen. Next, the mixture is compressed so that the added pressure, the needed pressure is given to them. Then what actually happens in the compressor is, since there is an increase in the pressure, so the gas molecules are going to get close to each other and they will be forced to react. Then the mixture goes to the converter. So this is a round tank containing beads, supposed to be beads here, of hot iron. The iron is a catalyst for this reaction. So the reaction in simple is this. And note that this reaction is very reversible. Then the mixture is cooled until the ammonia condenses. The unreacted gases of nitrogen and hydrogen are pumped back to the converter for another chance to react. The ammonia is run into tanks and stored as a liquid under pressure. When you change the pressure, it can also change the state. So what are some uses of ammonia? It is used in the refrigerating plants as a refrigerant. It is used in the manufacture of explosives. It is used in the manufacture of plastics and glue. It is used in the manufacture of nitric acid. So all these uses, and the importance of each of them. That's why ammonia is very important and it was worth discussing. It is also used as a cleaning agent. It is used in the manufacture of fertilizers. So this last point of fertilizers is the one that's going to end this discussion. It's going to be very short. So these fertilizers have got issues. The chemical fertilizers, that's why sometimes they are preferred. They are not preferred as to natural fertilizers. So the chemical fertilizers tend to make the soil acidic if they are used for long periods of time. Also, the chemical fertilizers are easily leached away. To be leached is you apply fertilizer to your garden, then let's say there is water, it is raining, the rain washes away the fertilizer, meaning that the fertilizer is not going to serve its purpose and it is a waste. So they are leached because they easily dissolve in water and move with it, making them wasteful. So these are the negatives of using chemical fertilizers. This marks the end of this discussion. Hoping to see you in a short discussion, which is pollution. Happy solving.